Disclaimer. This presentation session was prepared or accomplished by Cupid Chan in his personal capacity. The opinions expressed in this talk are the author's own and do not reflect the view of any United States government agency or department.
Good afternoon. 午安. Okay, give me some feedback. Good afternoon. Okay, thank you very much. You know what? This section, I actually have two big challenges. Number one, this is the last presentation for the whole summit. So I need to keep you here, keep you awake. So this is challenge number one. And challenge number two is, shall I speak in Chinese or shall I speak in English? So I grew up in Hong Kong. My Mandarin is not very good. So I decide, instead of confusing you by speaking in Chinese, we have professional translator right back there. So I will rely on them to translate it for me if you need it. So 我在香港长大了，我的中文是跟张学友学的。所以呢，如果今天不是说1000个上次旅游啊，每天爱你多一些哪一些 topic 的话，我 prefer 就是讲英文就好了，好吧？开始。首先I introduce myself. I'm the CTO of Index Analytics, one of the small business in United States, focusing on the government contracts. And at the same time, I'm also the board of director and the technical steering committee for Linux Foundation, ODPI. You know Linux Foundation, and this summit is actually organized by Linux Foundation. And they have different projects. ODPI is one of the projects focusing on data. And I am, this year, I'm the board of director for ODPI. So that's one of the reasons why I come here and talk to you about what is AI. And here is my contact information. Even though I will speak in English, if you have any question, stay behind. I try my best to talk to you in Chinese for the Q&A section after the official wrap up for this section. Okay, so let's talk about something 2 years ago. You know, where is it, right? Let's see. Here, this is the Singapore. And 2 years ago in Strata Data Conference, so I was one of the speakers. And then in the conference, they give me some souvenir. This and this. Can you guess what? I think you all know what is that, right? This is playing card. And this, can you guess what is this? Huh? This is actually a pack of dice. Can you see that? Okay, so of course, I also get this thing. Where is it? Yeah, I also get this cute cartoon drawing for me. I'm not sure whether it looks like me, but it is me. So it took me some time to think about why in the data conference they will give me this souvenir. I will share with you the answer. But first of all, let me play a game with you, okay? So hopefully I will not get any feedback when I step here, okay? So the easiest thing first. This is a coin, okay? If I flip my coin, what is the possibility of getting a head? What is the possibility of getting a head? 50%. Good. You guys are still awake, right? So I have a pack of dice here. This time, I get 2 dice instead of 1 coin, okay? If I throw the dice, what is the percentage of having like 2 6 here?
Under 3.
Sorry?
Under 3%.
1 over 36. Why? It's 1 over 6 times 1 over 6, right? Now, this is a tricky one, and this is the hardest one. And let me see if you can get it right, okay? This is the regular deck of cards, right? So, for example, if I flip it, you tell me to stop. So,
Stop.
Okay? So, help me to keep it right here. You pick it, keep it yourself. Okay? Your turn.
Stop.
Okay, almost done. Keep it yourself. And how about you? Stop, okay? So there are 3 cards, right? What is the percentage if I guess all 3 cards correct? What is the percentage of getting all 3 cards correct? Can someone guess? 1 over. Okay, how about this? 1 over 132,600. And the way it works is 1 over 52 times 1 over 51 times 1 over 50. That is this number. If I can tell you, this is spade of 3, this is the club of 7, and this is the heart of queen, and I guess all right, what do you think? And please raise your card and show the audience back there. Raise your card and show that club of 3, like, yes, spade of 3, club of 7, and heart of queen. Raise it so that they can see that. Yes. Hey, come on. Yes, you can call me AI magician. And I'm ending this talk. Just kidding. All right, so, AI and possibility or probability is very related to each other, because that's basically the foundation of why AI is so powerful, the probabilistic formula. Of course, when you club all that together with matrix, manipulation, calculus, differentiation, integration, you will sometimes get something like this. This is the cheat sheet for AI machine learning algorithm. Can you guess? This is very complicated. And when I think about why a data conference, they will give a pack of dice and cards to a speaker, then I realize, you know what? All this are probability, and AI data are relying heavily on probability and statistics. I come from US, Washington, D.C. And then here, this is one of the theme park in Pennsylvania. It's called Hershey Park. And then for those who have not been Hershey Park, this is just another theme park like Disney. But they have a lot of chocolate characteristics like this. I think China also have this Hershey chocolate, right? And then for a theme park, there are rides, roller coaster for people to join. And then, when there is a ride, there is a long line for the ride. And then suddenly, my son, a 2nd grader kid, asked me, "Hey, Dad, what are you doing at work?" Wow, very good question. At work, I will first of all gather all the data using ETL process, and then trying to apply some naive Bayes and try to plot the data. If the data is not really that satisfying, then I will apply deep neural network, and then hopefully the result will be better. Do you really think that's how I explain to my son what is AI? Of course not! Not because he is not the right audience to understand the context. And secondly, I do not want him to think, "Hey, my dad is crazy. He's just telling me something that I cannot understand, and stop asking me questions." So what I told him is AI is actually something that you will ask the computer, or computer will help you to do something that no one would know. It's actually the computer doing that, not you doing that. It's actually not proposed by me, it's by Alan Turing. And he is actually one of the very first pioneers of defining what is AI. And so I would say if something like this is called AI, but my son replied and saying that, "Dad, does that mean if I can ask the AI to do the homework for me, and the teacher will not know it's not me, but it's not the computer, but it's me doing the homework, that's AI?" Kind of, but in order to correct his perception on AI, I further explain. do you still remember how did you teach your younger sister a pen versus an apple? So basically you bring a pen and then you say, hey, a pen. And then you bring up an apple, you say, this is an apple. And hopefully by keep repeating this, you will teach your younger sister what is a pen and what is an apple, right? So, like, why? Because she start realizing the red round thing for that is like a pen, an apple, right? And the long pointy thing, it's a pencil or pen. And this is supervised learning because you map the input to the output. Here, the pointed, round, red, long, those are the feature in machine learning. And apple and pen, they are the label for machine learning. And then my son said, oh, Dad, I really remember this. I think this guy is actually talking about apple. I have a pen. I have apple. Apple pen. I have a pen. I have pineapple. Pineapple apple pen. Not really. Not this guy knowing machine learning or AI, but at least if he can help my son, a second grader, to remember or understand what is supervised learning, I will just let it be. And in reality, in the real life, supervised learning has a lot of application. This is one of them. So instead of a baby or a kid trying to remember what is a pen and an apple, it's actually a computer replacing the kid. The pen and the apple is replaced by this kind of MRI scan. Who is the parents or who is the bigger brother? It's the doctor. The doctor will tell the computer what is this cell. Is it a cancer cell or not? So through this repeat process, the computer will start recognize what is a cancer cell. So one of the applications for machine learning. I'm not trying to be the expert to explain to you what is the law of entropy or second law of thermodynamics. But in a very, very summarized case, it is actually saying that unless you put extra energy to keep everything in the state, things were just going to be messier and messier. So that's basically the very high-level explanation of law of entropy. Now, if we apply to a kid's playground, what that means is unless you really spend time to clean up the playground after you play with that. The playground from time to time, it will become something like this, very messy. And then in my house, it's actually my mother-in-law taking care of this kind of responsibility with my kids. So one incident, my mother-in-law went back to Hong Kong to take her break. So guess what happened? The whole playground is becoming so messy to a point that my wife said, I don't care how you do that. Before your grandmom comes back from Hong Kong next week, clean all that up. My wife did not give any instruction, but just asked them to clean up the playground. And guess what? In the next 2 hours, the kids will try to, like a bundle or group, all the 4 wheels boxy thing, and they call it cars. All the fluffy things, they group them together, they call it stuffed animals. And then all the blocks that can stack together, they put it inside one box, and they call it Lego. Without being given any instruction, they can uncover the pattern of the messy playground. And then in machine learning, this is called unsupervised learning, is to uncover some hidden pattern inside the data sets. And then in the real life, unsupervised learning can be used for grouping the customer together. So for example, how many, what's the income for certain people? And where do you live? Do you have kids or not? Have you married? You throw everything into a computer, and the computer will try to group those people together. And then, hopefully, in the marketing campaign, you can target certain group of people based on the characteristics that the machine can find for you. So this is one of the applications for the unsupervised learning. And for teaching a kid, you know that it's not always true that you keep showing them the pen or pencil is the most effective way. No, it's not just trying to tell them, hey, do this, and then they can uncover certain pattern. Sometimes you need to award them if they do something good, and then punish them if they do something bad, right? It is called reinforce the behavior of a kid. And then in machine learning, same concept also happens. And we call it reinforcement learning. That is, when the system performs something, let's say a robot, it's performing something good, you add a point to the system. But if the system does not perform as you expect, you reduce the point from the system. And in AI, this is heavily used in robotics. So let's imagine, for a robot, you ask the robot to walk in a straight line, okay? And then it fell down. Because the robot has the motor and the sensor around the robot. So all the data is collected and then feed it into the system. So that when it falls down, it knows, oh, when the motor like this, then it will fall down, so next time it will avoid it. But when the robot successfully steps up one step, 2 steps, then all this will also be recorded and then being tried to fit it into the model and help the system to learn as the time goes. So that's the reinforcement learning for the machine learning. And then so far we cover supervised, unsupervised, and reinforcement learning. And these are the major branch for AI. But that's not the end, because when we think about how to teach a kid what is AI, you know, one of the very popular question a kid will ever ask is why? I think for those who have kids, you experience that. But besides asking the question, why? The other 2 very popular questions that a kid will ask is, like I'm talking about when they're very young, when they first learn how to talk, and then they first learn how to interact with people. They will ask, hey, how old are you? Or, are you a boy or girl? So they will also ask this kind of question. And believe it or not, this is also the fundamental for an AI algorithm that needs to understand. How old are you is a number. And then in machine learning, it's called regression because you are trying to predict some certain actual number. And are you a boy or a girl? That's the grouping, that's the classification that a machine learning algorithm has to understand. So those 2 are actually key questions, not only for a kid, but also for machine learning. Let's review very briefly how kids learn, right? So, first of all, this kid will observe the world, what is happening. And then, from his little mind, they will form some rules to predict or to give you an answer of whether it is an apple or it is a pen. Let's take a look at this as a developer. Let me go back and forth to show you. Do you see the difference? Yes, there is a difference, but the difference is not a lot because as a developer, the developer also observes the world and then they program using the rules, the if, then, else, where, case, statement, all this are the rules to define or to give you the result. Of course, you hope the result is good, and if it is good, you keep using that. If somehow there is a case that like the rule breaks, then you start incorporating another newer rules, hopefully to take care of that exception. Now, in AI, look at that. In AI, the developer will no longer be in this position. It will pull out himself right here, and then the AI algorithm is the one to get all the data, to collect all the data, and then fit in and provide a model as a result. So guess what? All this will then become self-sufficient. This is why AI is much powerful than the traditional way of programming, because all the developer do is to formulate the AI algorithm, and then the algorithm, as you feed more and more data to the algorithm, then it will learn better and better, just like this model we're improving. You may have heard about give a man a fish, you will feed him for a day, but if you teach a man to fish, you feed him for a lifetime, right? So now, let me borrow this and then convert this to Cupid proverb. That is, give a computer a code, you will actually help it to solve only one situation. However, if you teach a computer to code, you are helping this computer for solving a collection of situations. This is the real reason of why AI is so powerful. And when we talk about AI, we need to think about what is memorizing versus generalizing. And the goal here is not to understand, not to just memorize what is 2 plus 1, because when you teach your kids what is 2 plus 1, they will say 3. Are you sure you know what is 2 plus 1? They say yes. Then you ask, what is 1 plus 2? They say, you haven't told me. I don't know what is 1 plus 2. But if you really understand, memorizing is just like know how to do it exactly. But generalizing is really understand what's the point. In machine learning, we want the designer like an algorithm like this. Overfitting means memorize the answer. It's not something preferable. Underfitting is also not preferred because it's just randomly throw something in the dark, and then they may get an answer randomly. So this is also the concept for machine learning: underfitting, design, or overfitting. Now, if we apply this for overfitting, you will treat actually this spot as a human. We understand this is actually bad, right? This is the exception that you want to avoid. But if you're overfitting, you will treat this spot as normal. So that's you want to avoid, especially for fraud detection. You know that this is a fraud, you want to catch it instead of treating this as a normal. And in US, McDonald's, they will have something called Happy Meal. I'm not sure whether they have Happy Meal here, but one of the very interesting thing is they're not only selling you the food, the hamburger, they will also give you a toy for Happy Meal. And then one of this toy is called Guess Who. The rule is you have all this card, and then you try to guess, like you have 2 packs. You try to guess which card are you holding. And if I can guess you right, I win. If you can guess me right first, you win. And I observe my kids to play this game. At the first, what they are doing is they basically look at themselves, look at the card they have, and scan through one by one. Are you having the one fishing? Are you having the one playing soccer? Are you playing the one playing like guitar? But a few days later, they actually figure out a better, smarter way. They will ask a question like, do you have the one wearing anything? Maybe a glass, maybe something, but wearing anything. Or do you have the card with purple in that? So what they're doing, they try to narrow down and build their decision tree. This is also one of the very popular algorithm in AI. But not only the kit, but AI machine learning also have this. But the whole process of developing this, it's actually as easy and as foundational as the kids playing game. Of course, for human, guess who may be the game for mastermind, which require a lot more algorithm, much more sophisticated algorithm. And if we play Go, decision tree may not be enough. So depending on which game and which situation we are targeting, we will have different kinds of algorithm. And this is only a rough categories for all the AI algorithm ever exist so far. And you can imagine, as we learn more, as we derive more, many other algorithms can be derived. This is Tesla, and this is Uber. Uber actually is the Didi in China, okay? So, can you tell me what is the difference between these two companies and what's the same for these two companies? First of all, let me ask you, what is the same similarity for these two companies? Anyone? I actually hear some answer already. What is that? Car industry. Tesla, it's like inventing a car, and Uber or Didi is also the car. But what's the difference? Tesla reinvent the whole engine for the car, the technology of the car. Uber or Didi, they did not invent anything new. They use map, they use app, they use GPS, which is like already exist technology in the business model. Why do I bring this up? Remember this question my kids asked me? So AI can help me to do homework and the teacher will not find out that I did not do that, right? So I know from the bottom of my heart, I will be so proud of my second grader kid if he can really invent the AI algorithm to fool the teacher that it's the machine doing the homework, but not him. But I will be equally proud of him if he can just utilize the AI algorithm someone else created, and then he applied to do the homework for himself. So why is it matter? Because there is no right or wrong answer when you're dealing with AI. It's only right or left, depending on what kind of path that you're picking. Sometimes you may want to invent the technology, and sometimes you may want to utilize the technology. And this is also the main, like the second part of this conversation, this section. When an enterprise, when a company saying that I want to invest in AI, the company has to understand which part of AI you want to invest into. You may want to invest in some like a technology so that you improve the AI algorithm. But you may be as simple as utilize the AI algorithm that the other people has invented for you. Either way is good. It's just a matter of which way you are going to use or employ. So now, I think like another big key point I want you to take regarding to this section is BI is dead. BI, the traditional BI of the reporting and the dashboarding is dead. Especially for a second grader kid, they have already understand kind of the AI concept. But BI is dead unless you incorporate AI and other approaches in your BI strategy. That's the remaining 5 minutes. I know that I have 5 minutes left, so you don't need to raise the card for me. It's 4 areas to conclude my talk. in order to make sure that your BI is actually running okay when the AI is so prominent right now. The process, framework, architecture, and principle. Let's go through them. Number one, process. Take a look at this. CRISP-DM. This is the cross-industry standard process for data mining. Look at this. AI is actually right here in the modeling. The whole process started from the business understanding to the data understanding and try to prepare your data before you can really model. Before AI, modeling is actually done by manually. And then evaluation and finally deployment. So that is the process. So remember that if you have the BI strategy, incorporate AI into that, in the modeling. And next is the architecture. Architecture is the one here I show technology agnostics. You cannot find Oracle, you cannot find Cloudera, you cannot find SQL Server in this architecture diagram because I intentionally make it technology agnostics. This is the second point that when you build up your BI strategy, keep in mind, you should not take a look at the technology first. But then, you still need to follow some principles. And these are the 6 principles. For example, to have like a single version of truth for the data. And it should be open ecosystem. And apply API to that and provide the self-service analytics to your users. Those are the key principles for applying the AI to BI. And finally, framework. We need a framework to have it. So first of all, the solution. Of course, we have the solution. But once we have the solution, we need to outreach so that the other people will also understand what you are talking about for this solution. And then we need to develop the workforce. So they know that now you need to develop so that not only you have the skill sets, but also they can also be capable for doing this. That's the workforce development. And enabler, that is, we apply different things to enable all this together, and this we call the Seoul framework. And all this, you don't need to take the note because if you have the cell phone, this is the QR code for my YouTube channel I have just started 2 weeks ago. So, and the very, very first video that I have, it's talking about how did I teach my second grade kids about AI, okay? And some people say, very good story, Cupid. That's for presentation, I like it. But I don't really think you teach your kids about AI as the way you told us. Tell me what is AI?
Artificial intelligence.
What is it exactly?
Artificial, it's supervised learning, unsupervised learning, and reinforcement learning.
What exactly is supervised, unsupervised, and reinforcement learning?
Supervised learning is when you bring something to the computer and the computer remembers it. Unsupervised learning is when you tell the computer to do something and you don't tell him instructions. Reinforcement learning is when the computer does something right and you give him a point, and when the computer does something wrong and you take away a point.
Yeah, good job. So now I can tell you this is a true story and the background is in Hershey Park and I did not make it up, and this is how I teach my kids AI and how is it applied to BI. Thank you very much. And so, do we still have time for question and answer? Huh? Okay. So, maybe we may not have time officially, but if you can stay behind, we can talk. We can still talk. Was that okay? Okay. Thank you very much.